Gravity pulls equally everywhere, right? So why do people weigh less at the equator? Think about it. You're told gravity is this invisible hand pulling down with the same strength on every person, no matter where you stand. But the numbers don't match. People at the poles weigh more, people at the equator weigh less. Isn't that weird? If gravity is consistent, why should geography change your body weight at all? That's not just a fun fact. It's a red flag. The official story says it's because of centrifugal force. Supposedly, as Earth spins faster at the equator, it flings you outward just a little, counteracting gravity. But wait, if this spin is strong enough to change your weight, shouldn't we feel it? Shouldn't oceans bulge dramatically? Shouldn't planes constantly adjust for this force, tossing everything sideways? Nobody feels it. Nobody notices it. Yet the math insists it's there. Doesn't that sound almost patched together? Here's where it gets interesting. Some researchers point out that the difference in weight is only a few pounds, but that's enough to prove the equal gravity story doesn't hold. So the explanation shifts. First it's gravity, then it's centrifugal force, then it's Earth's oblate spheroid shape. But isn't that just stacking fixes on top of more fixes, like duct tape on a cracked mirror? The more you stare at it, the less clean the story becomes. And here's another curveball. If gravity is strong enough to hold oceans from flying off a spinning ball, how is it weak enough to let a bathroom scale at the equator cheat a couple pounds? Imagine gravity as this ultimate, all-powerful force, yet it loses to a spin you can't even feel. That's like saying a brick wall can stop a speeding car, but not a paper airplane. Something doesn't line up. Picture this, two friends, one living near the North Pole, one chilling in Ecuador. They're the same height, same build. One steps on the scale heavier, the other steps on the scale lighter. Same Earth, same laws of physics. But the middle line bends reality. How does that make sense unless the story is missing pieces? Some people ask, what if weight differences aren't about invisible forces at all? What if they reveal something deeper about the way the world is actually structured? Something that textbooks kind of smooth over, with tidy formulas, and those just trust the math explanations. Isn't it funny how every time a crack appears, the answer is never, maybe the model is off. It's always, here's another patch. So next time someone says gravity works the same everywhere, ask them, why do scales disagree? Why do official sources need 3 different explanations stacked like excuses? And most importantly, why do we keep accepting answers that generate more questions than they solve? What if the Earth isn't the way you've been told? What if these little weight glitches are clues that point to something bigger, something we've all kinda overlooked? Follow if you want more late-night questions that keep scientists awake and make you stare at the ceiling wondering, what else don't we know? This video is for entertainment purposes.